For those of you listening at home,
Hi, Polly.
hi Polly.
Hi, Paul.
We are going through homework 8A-1. I'm going to do this verbally. I can do these on the board if you'd like. But all of these are going to be sinusoidal. They're going to be smooth up and down, up and down, up and down forever. I'll just tell you where they start, where the max, base, and min are, and that should be enough. And what do you count by? Number one, y equals cosine of x. It should. Go ahead.
Yeah, this is gonna be kind of hard to give us the interesting.
Well, I know. The max should be 1. The minimum should be -1. The baseline is 0. The very first dot, it should be counting by 5 or 2s, although they did that for you. The very first dot should be 0, 1 at the maximum. The next dot should be on the baseline, then the min, then the base, then the max, then the base, then the min. Does that make sense? Everybody follow that? Okay. Number 2, maximum is 1, minimum is -1, baseline is 0. The very first dot is at 0, 0 at the baseline. From the baseline, it goes to the max. Then the base again, then the min, base, max, base, etc. Never read so far? Number 3, whoa. Sorry. Screen just went spazzy. Number 3. Down. The max is 2, the min is 0, the baseline is 1. And then it's just like a regular cosine. The very first dot should be 0, 2 at the maximum. Then the base, then the min, then the base, then the max, then the base, then the min, etc. Number 4, the max is 3, the min is 1, the baseline is 2. You should have the first dot at 0, 3, the maximum. Then base, then min, then base, then max, etc. Everybody okay up to number 4? Number 5, the max is 4. The min is -4. The base is 0. The first dot should be at 0, 4 at the maximum. Then base, pi over 2 comes 0. Then the min at pi comes -4, and then etc. Questions for? Okay, number 6. The max is at 3. The min is at -3. The base is at 0. The very first dot should be at 0, 3 at the maximum. Then base, min, base, max, base, min. Number 7. The max is 6. The min is -2. The baseline is 2. The very first dot should be at 0, 6, which is the max. Then the next dot should be a height of 2, then a height of -2, then a height of 2, then a height of 6, etc. Number 8. The max is 1.5. The min is 1/2. The baseline is 1. The very first dot should be at 0, 1, which is the baseline. Then it should go up to pi over 2, 1.5. Then pi, 1. Then 3 pi over 2, 1/2. Then 2 pi, 1, etc. Then you repeat up to number 8. Okay, number 9. The max is 3. The min is -5. The base is -1. The very first dot should be 0, 3 at the maximum. Then it should go down to a height of -1, then -5, then -1, then 3, and so on. Number 10. The max is -1.5. The min is -2.5. The baseline is -2. The very first dot is 0, -2, which is the baseline. Then it goes up to the max of -1.5. Then back to the base, min, base, max. Number 11. Max is 1, min is -5, baseline is -2. So the very first dot should be at 0, 1, which is a maximum. Then should be have a height of -2, then -5, then -2, then 1, and so on. And last but not least, max is 3, min is -5, baseline is -1. The very first dot should be at 0, 1, which is the baseline. Should go up to pi over 2, 3, then pi, -1, then 3 pi over 2, -5, and so on. And it repeats. All right, questions? Any of those who want to see analyzed? How were these? Easy, hard, medium? Yeah. Everybody's feeling semi-comfy on these at least? Okay. Let's take out your notes. Let's try a little more beefed up version. I'd like to graph the following. This is a full-fledged standard form graph. First things first. Can anybody identify the four numbers A, B, H, and K in order? Go. A is 4. B is pi over 10. Keep going.
H is 3.
It is 3 because subtraction is built in. And then K is 1. Correct. A, B, H, K. The minus sign is built in. It's kind of like point slope form in that respect. And it's kind of like the parabola form, vertex form. Any input is going to have a minus sign in it to make up for the fact that it goes backwards. It does the opposite of what you expect. Can anybody name the 5 parts of a cyclic graph? The 5 parts of, what do you call a sinusoidal graph? Go.
Baseline,
Baseline is first.
amplitude,
Amplitude.
horizontal shift,
Hold on a second. And then horizontal shift, okay.
period, and then quarter period.
Period, and then quarter period, correct. Can anybody tell me how to get the baseline? Where do you look? Of these parts, which one do you think is the baseline? Go. It's K, correct. There is a letter I want equals, because it is a horizontal line. What equation would that be? What equals K? Y equals K, good. The base is Y equals K, baseline. Can somebody tell me how to find the amplitude? Yeah, good. I don't need the Y equals for this time, it's not an equation. But absolute value of A, absolutely. And while you're at it, horizontal shift. It's pretty easy. It's H. Now, if H spaces to the left or to the right, you'll have to tell me when the time comes. So you might want to put that in parentheses. The horizontal shift is a number, but then you'll have to tell me whether it's that many spaces to the left or that many spaces to the right. This will tell you if it's positive or negative. How do you get the period? Check box.
Oh, shoot, how did you get the period? It's 2 pi over b.
Correct. Where do you get the 2 pi from?
That's the general.
Correct.
thing.
And then why are you dividing by b instead of multiplying? Because they multiply by b. You're right. But why are they dividing by b instead of multiplying? Because here's b,
So
5
you're
or 10.
taking it out of the equation?
Yeah. Where is it physically? It's part of the what?
Oh, it's part of the in.
Go ahead. Yeah, go ahead. Part of the input. An input always. What? Input always does
The opposite.
opposite of what you expect. Instead of multiplying by pi over 10, we're going to divide by pi over 10. We'll do that in a moment. And then the quarter period is just what? Anyway. Yeah, 1/4 times the period. Does that make sense? All right, let's find this. You do these in order. Can somebody tell me the baseline for this particular problem? Go. Yeah, y equals 1, correct. That's the first thing I would write, by the way. Go to 1 and put a dotted line. Go a decent distance to the right. What I would like you to do is include 8 periods worth. 8 quarter periods, I should say. Let's just say 2 periods, that's probably easier. So 2 full cycles. 2 complete cycles. So you got y equals 1, there's the baseline. Michael, take over. Where's the maximum? I suppose I should ask ahead of time, what's the amplitude?
4.
Yeah, the amplitude is 4. The absolute value of 4 is 4. So use that. Where's the maximum?
5.
It's at 5. It's 4 spaces up. And where's the min?
-4.
This is at 5, and this is at 1.
Oh, yeah. So, 3. -3.
-3, okay. So down here at -3 is the minimum. Your graph is going to be in between these two lines and centered around the middle line. Does that make sense, Brian? So everything is going to be wobbling in between these two extreme lines. Pete, take over. What is the horizontal shift?
3.
3. And is it 3 to the left or 3 to the right?
3 to the, 3 to the right.
Correct. Why do you say that?
Because it's +3.
That's true. It is +3. There's something in here that would tell you you're going to the right.
Oh, well, it's -3 and it does the opposite of what you expect.
Exactly. It's subtracting 3, but it is the opposite of what you expect. So if this were x plus 3, you'd actually be going to the left 3. Okay. While you're at it, give me the period of this graph. P equals what? How do you find it?
Well, 2 pi over pi divided by 10.
Right. 2 pi divided by a fraction. How do you do that?
Would you multiply the denominator by the reciprocal?
You multiply the whole thing by the reciprocal. What is the reciprocal?
10 over pi.
Good. How do you multiply a fraction times a whole number?
You put the whole number over 1.
Yeah. What happens now? John, take over.
You just get 25 over 5.
True. Does that reduce?
Yes.
Sure.
20.
20. The pi's cancel. And you have 20. While you're at it, what's a quarter period?
5.
It's 5. It's 1/4 of 20, which is fine. Why do we care about the quarter period?
Because that's what we're counting by.
Yes, that's what we're counting by on the x-axis. Now, somebody else tell me, where do I put my first dash on the x-axis? Do this, Ishan. What's that? 3, exactly. A lot of people put it at 5 because they get so excited about the quarter period. The horizontal shift is the starting period point. And I would suggest putting the number way down here so you don't run over it with the graph. What's the next dash after that? We're going to need to do 2 full periods. How many quarter periods would that be, by the way? I'm sorry. No, I mean, if there are 2 full periods, how many quarter periods would there be? Sorry. No, should I know? 8. So a quarter period is 1/4 of a period. So if you have 2 full periods, chop them into quarters, there'll be 8. The reason I brought that up is that I want 8 dashes beyond your starting point. Make sense? So Julie Sishan, take over again. Where's this?
8.
Yes, keep going. 13. And I've got a trick on this too, by the way. Close. 18. 23. 28. Keep going. Yep. 38 and one more. 43. Good. Sometimes if the jump is a little awkward, you notice that if you have 2 jumps, it would be 10, which is really easy. That's sometimes what I do. 3, 13, 23, 33, 43. And then if I just do the first one, it'll be 8, 18, 28, 38, blah, blah, blah. That's kind of lucky because 10 is nice, but that's good. These numbers are important. I need to know, oops, this number's important too, and I forgot to include it. If you do not write these numbers, I will take off at least half points because I don't know what the graph is. Part of it is, you notice that, like in this assignment, the graphs all look kind of the same. If we didn't know what the scale was here, I wouldn't know what your graph was. So these are at least half your points here. Make sure you count correctly on those. All right. Where do I start? Where's the first graph point? Here's your hint. It's a sine graph. Okay. Ah, yikes.
That's hack marker.
Go ahead.
Where do you have baseline?
Yes, at the baseline. You go over 3, but that's at the baseline. This is the center of the graph. Where would it go from there? Would it go up or down?
Up.
Goes up to the max, then what? Base, keep going. Min, base, max, base, min, base. Be careful, sometimes it's tempting to put dots on the x-axis, because it's so close to the baseline. Be careful, don't do that. They have to be on the baseline. And then, what kind of graph do I draw? Sophie. Yeah, curvy. Make sure it's not sharp, pointy teeth.
Sometimes it's kind of hard to make it pretty. Is it like, okay, is like something like this, okay?
Yeah, it's fine. As long as it's not an actual like angle.
Okay.
Yeah, those scare me. But as long as they're at least curved a bit, it doesn't have to be artistically perfect. As long as it looks like it's curving, we're good to go. You actually did a fairly complicated sine graph. As long as you know the 5 parts, and you know what order to graph them in, you're good to go. I do need to introduce a few more quick things. These are sort of a teaser for next week. Oh, actually for tomorrow even. Does anybody else need this left-hand side? Okay. I need to show you one thing that was not incorporated into the notes yet. What if I did this? Y equals negative sine of x. Go ahead and write this down now. Now, y equals sine of x, we've done several times by now. Y equals sine of x, it has a max of 1, a min of negative 1. You're counting by pi over 2, pi is 3 pi over 2. 2 pi. You notice we were not counting by pi's over there? We were just counting by plain old numbers. That's kind of an accident. That's because b was such a strange number. The pi's just happen to cancel. They don't always. Here, the period is 2 pi, so the quarter period is pi over 2. Where does the sine graph start? This way? Yeah.
I'm sorry, why did you go to the negative?
Oh, this is just to compare.
Oh, got it.
Yeah, good question.
I thought you were just getting rid of it.
I know. No. That, let me think about that. That is 2 pi over 2, 1 pi, 3 over 2, 2 pi. Okay, so we're going to compare these side by side. What does a regular sine graph look like? Michael, where do you start? I'm sorry?
Start at the baseline.
At the baseline. And then where do you go? Up. So max, base, min, base. Should look like this. Does anybody have any idea what negative sine would look like? Yeah,
Would it go down first,
it would. Where would it start?
the baseline?
Yeah. What's the height at this very first point?
Right now,
Yeah, 0. Make that negative.
0.
It's still negative 0, which is 0. In other words, all the heights are going to become negative. It goes down, then base, max, base. It's the same sort of pattern, only it goes down first. Did you see that? Can anybody tell me what a y equals negative cosine graph would look like? Yeah, no.
So it would start, on the minimum.
Correct. It normally starts at the max, but it'll start at the minimum.
I have a question.
Go for it.
Say it's like y equals sine of x plus 1, would you start at negative 1?
So negative sine of x plus 1, you're saying?
Uh-huh.
Okay. This would raise the entire graph up by 1. So, in other words, it's always going to be base, min, base, max. Like wherever the baseline is, start there. So yes, it would start here, then go to here, then here, then here. Okay. Negative cosine starts at the min and goes where?
Up,
Goes up to the
baseline,
baseline,
then max,
max,
baseline.
base,
min.
min. Exactly right. In your notes, I'd like you to write this, and this is one of the last things you need to write in your notes for today, of course.
Ever.
No. I still got a lot of trees to kill on your behalf. So, these are what we call quick graphs. Or quick sketches. In other words, it's a really short way to remind yourself what the basic graph looks like. Do some little teeny miniature graphs here. What does positive sign look like? Basically, where does it start and where does it go? And when I say where does it start, it either starts at the base, the max, or the min. Where does a positive sign graph start? That means regular sign, basically. Yeah. At zero, at the baseline, and goes where? Up. So start at the baseline, goes up. That's what a quick graph of positive sign looks like. So every positive sign graph in the world will look like that. Starts at the baseline and goes up from there. What would a negative sign graph look like? Good decision. Correct. Start at the baseline and go down for a cycle. There's the center of the graph. Every negative sign graph in the world will look like that. How about positive cosine? Pete.
It started at a height of, well, it would start above the base,
Correct. At the what?
at the max.
At the maximum and go, and it has to go
It has to go down.
down. It'll go base, min, base, max. Be careful. I've actually had somebody do this. It was not here at Sacred Heart. It was at a pretty good school, whose name I won't mention. I love them dearly, but this was, and they were actually pretty embarrassed once they discovered it. They did this. Here was their quick graph. Start at the max. Let me see what's wrong. Yeah, this is not the maximum anymore. Maximum means it can't go any higher, and then if you shoot higher than that, it's like, whoa, you just broke something. So this is bad. So don't do that. There's no trig graph that does that, basically. What about negative cosine? Sophie, where does it start and where does it go? Positive cosine does. What about negative cosine? Starts at the, not at the base, that's sine. Sine is the only one that starts at the baseline. Cosine starts at the maximum. What about negative cosine? Exactly. Starts at the minimum, and then there's no choice but to go up. That's what a negative cosine graph looks like. Memorize these. That'll probably be a test question. I'll say, give me the quick graphs for positive sign, negative sign, positive cosine, negative cosine. On the test, I'll eventually say positive tangent, negative tangent, because we're going to be graphing those next week. But for now, don't worry about that next, yeah. Making sense so far? Let me hand out the next thingy. Here we go. I am not going to assign the entire thing for tomorrow, just pieces, but I'm going to have to skip around because some of these are relatively easy and some of them are not. Actually, I take that back as far as being the last bit of notes. Sorry, there's one last thing I have to tell you. Did I miss anybody? Look at this. Okay. Let me show you. Can somebody, I'm going to have to move job with somebody. Number 2. Tell you what. I'll cut you a deal. Number 2, I'll do it with you if you allow that to be the last note. You can write it right on the worksheet if you want. Or you can put it in your notes, up to you. Number 2. Can somebody read out what it is?
Number 2, y equals 1/2 cosine parentheses theta minus 3 pi over 4 parentheses plus 2.
Okay, plus 2. Good. Did I do any period changes in here? No, did I? Okay, I just figured out which ones I'm gonna assign for tonight. I'm just assigning 1, 2, 3, and 4. Now, there are a few numbers missing. Although I just treat theta as x. It means the exact same thing. Can somebody name the parts of a cyclic graph?
Do we have to name the rest of this?
Not necessarily, but it'll help you actually graph it. So, what are the 5 parts that you need in order to graph? Michael, what's the very first? Baseline. Correct. What's the next one? Amplitude. Next.
Well, periods after that, and then order periods, but,
Something before that.
oh, minimum? Oh, horizontal,
Horizontal shift. And then period and
order period.
quarter period. Correct. Can someone tell me what the baseline is in this particular problem? What equals 2? Y equals 2 is next. I do want the y equals. I will take off a point or two if you don't, because it is an equation. Y equals 2, because then we give me the amplitude.
Well, actually, it's 2 and a
Right.
half.
Is what I'm sorry?
1/2.
It's 1/2. It's the absolute value of 1/2, which is 1/2. What's the horizontal shift? Sophie. 3 pi over 4. To the left or to the right? To the right. Correct. That's going to be your starting point. Can somebody tell me how to find the period? You might notice this thing is not in full form. There's something missing. Anyone notice? I like the 1/2. I like the cosine. But after that, there's no b. What should there be in this case? A parentheses. And then what number is in front of theta? 1. 1 parentheses theta minus 3 pi over 4. Friend plus 2. There's your b. B is equal to 1. Would b eventually be equal to something other than 1? Yes. Like if you have like a 2 here, you would actually have to factor it out like a GCF. We'll do that later. That's in the second part of this assignment. For now, find the period. Jack Clough. What's the period of this thing?
Well, it's 2 pi, because if it's 2 pi over 1.
Exactly. And what's the quarter period?
Pi over 2.
Right. Pi over 2. Let me see why it's 2 pi. Normally it's 2 pi and nothing changed. A 1 there means just 2 pi over 1, which is the same thing. Alright, let's graph this thing. What do you graph first? Noah.
The baseline.
The baseline, correct. Where is it?
2.
The baseline is a 2.
Positive 2.
Positive 2, correct. Okay. Can somebody, I'll do the dotted line. Make it long enough so that you can have 8 dashes. Do the decision on what is the max and what is the min.
All these worksheets only have 6 dashes.
Well, okay, it extended it again. Max is where? 2.5, good. And where's the min? 1.5. Right, because the amplitude is 1/2, so it goes up and down half space. So here's the base, max, min. What do we graph next? We've got the baseline, and we covered the amplitude by going max and min. What should we use next? To the left. We got baseline, we got amplitude. Horizontal shift, where is that? Yeah, which way? To the left or to the right?
Oh, to the right.
To the right. So I'm gonna just put a dash anywhere you want.
This already has,
Oh, does it actually have 3 pi over 4?
no, all of them have two, or pi over two,
Pi over 2, do they have little dashes in between them?
no, it's just like all of these.
Well, it has space in between.
It has space in between. It's really, really faint. There should have been a line in between them.
Okay.
What are those? Actually, I'll recreate that. Hang on a second. If this is pi over 2, and there's a dash here and a dash here, and here's pi, can somebody tell me what this is? What does it kind of have to be?
Pi over 4.
Pi over 4, it's halfway in. And if that's true, where's this? This is 2 pi over 4.
3 pi.
3 pi over 4. If you get stuck, count by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So your graph there, the computer sort of tried to help by doing counting by pi over 4s. No, question.
Well, what's like pi over 3? That's like a multiple of pi over 2, right?
Oh, if it's pi over 3,
Yeah, isn't this one pi over two?
let me look. This is,
Or not pi over three, 8 over four?
where was I? Well, this is 3 pi over 4, so it's gonna be here.
I'm thinking like number 1 or number 3.
Yeah.
Oh, gotcha. Let me look and see what the graph looks like on here. A, B, there it is. Go up a little bit. I see. Oh, that's annoying. What I would do is
That's S.
scribble out their numbers and just mark your own.
Can I just change like all the 2s, 3s to the bottom?
That's totally fine.
Okay.
What I would personally do is just draw my own sketch from the get-go. Just ignore their helpful graph. Freehanding it is actually a little easier than trying to fit into somebody else's graph. So feel free. If you want to just change the numbers so it works, great. If you want to just redraw the graph underneath, fine. I'm just redrawing it. So 3 pi over 4 is here. Center of the graph is here. Question, what kind of a graph is this? Is it a sine graph or a cosine graph? So, cosine graph. Here's another question I haven't asked you before. Is this a positive cosine graph or a negative cosine graph? Just look at it and take your best guess. Positive. Why do you say that? Correct. Right in front, it's a positive 1/2. This means it's a positive cosine graph. Can anybody tell me what a positive cosine graph always looks like? Starts where, goes where? Pete. Where does the positive cosine graph start and where does it go?
Starts at the max.
Starts at the max?
And goes to the base, and then to the max.
And then base at the max. Correct. Like that? Here's the center of the graph. See the center of the graph here? You went over 3 pi over 4, and the baseline is 2. Everybody look up here just so you see where I'm pointing. Am I going to put my first dot at 2.5, 2, or 1.5? Yeah,
2.5?
at 2.5, the maximum. What am I supposed to be counting by the way?
Pi over 2.
Pi over 2. Be careful you don't put your next dot on pi. That's only over pi over 4. So here's my first dot, here's my second dot, here's my third dot, fourth. This is actually one of the reasons why I like doing my own sketches. On the actual task, I'm just going to give you a lot of blank space where you can draw your own. It's actually less aggravation. So, I need you to label them though. Here's 3 pi over 4. What if you go over pi over 2? Where are you? Can you see? What would you label those? 5 pi over what?
What?
5 pi over what? Close. 5 pi over 4. Bless you. What you're really doing is adding 2 pi over 4. Get a common denominator. 3 pi over 4 plus pi over 2, I can't do it because it's not a common denominator. 3 pi over 4 plus 2 pi over 4, Now do that again. What is this? Anybody? 7 pi over 4, keep going. 9 pi over 4, you got like 4 more. 11 pi over 4, 13 pi over 4, 15 pi over 4, got it. 17 pi over 4.
You don't have to do that many, right?
Eventually you will, not on this one you don't. Eventually I'll ask you to do 2 periods worth. So get in the habit of thinking about that at least. But on the test, I will definitely ask you for 2 periods worth on all the graphs.
Are all of these cosine?
Are they?
Oh, no, no,
I
no.
hope not.
The whole first page is, and the rest is not.
Oh, okay. So the first dot was on the max. Where do you go next? Julie, see you. The baseline. Yeah, how far over? At what? Good. 5 pi over 4. The next interesting dash. So max, then base, then min, minimum, then base, max, base, min, base. It's going to be a very shallow graph. Make sure it's smooth, curvy. You're done. Does that make sense? Again, I think it might, if you used the graph already, feel free. Feel welcome to draw your own graph just from the get-go. It's on the back of the page or whatever. Especially on the ones that are coming up, there's no guarantee that they will fit onto the nice pi over 2 graph that they give you. You might just want to ignore those in 5, 6, and 7. Any questions?
So,
Yeah.
I think I'm just kind of confused. So if the horizontal shift is pi over 3.
Correct. In this particular
No,
case.
no, sorry, I'm talking about like number 1.
Oh, I see. Yes.
Then,
I'll just simulate
but the
that.
period
It's
is
pi over 3.
still 2 pi.
Let me look. That one, yes. So what's the quarter period?
2 pi over 4.
2 pi over 4, or just pi over
Pi over 2.
2. You're going to be adding pi over 2 with each jump. I'm going to use a different common denominator than the one from 3. 6. Yeah. So this would be adding 3 pi over 6. And I would change this to 2 pi over 6. So make a common denominator and then do the jump. Okay. That'll make it a lot easier. This will be 5 pi over 6 and blah, blah, blah. Everybody okay?
We don't know how to do number 5, 6, and 7, right?
You might be able to, but hold off, because there are a couple of details I need to show you.
One before.
5 and 6 are especially tricky,
Yeah.
until I show you how to do them. Number 7, I think you might be able to graph, ironically enough, which is the most involved one of all. But there's a trick to number 5 and 6 that I haven't shown you yet. Okay. So go to it, and let me know when you get stuck. And see you later, Polly. God bless your health. And I'll email this to you, okay? So, bye.